All right, so for this problem, we're also going to use integration by parts. So a trick to trying to figure out which one is best to use for you is to figure out which one would come first in this. So here I have x to the 3, which is algebraic, and then I have natural log of x, which is a log. So since this one comes up higher, I'm going to let my u be natural log of x. So I'm going to say u is equal to the natural log of x, which would then make the other part of this, the x to the 3, my dv. All right, so now I would need to figure out what the other portions would be. So if I take the derivative of the natural log, I'm going to get 1 over x dx. And then if I integrate x to the third, I'm going to get 1/4 x to the 4th for my v value. So now using this right here, we're going to first multiply u times v. So I'm going to write that our answer is going to be 1/4 1/4 x to the 4th times natural log of x minus, and I'm going to then integrate v times du. So 1/4 x to the 4th times 1 over x dx. So rewriting this, I would still have this whole part would remain the same. And then here, I would get minus 1/4, the integral of 1/4, and then x to the 4th divided by x is going to be x cubed, and then dx. So now, after going through to actually do the integral, so I'm going to get minus 1 over 4, going to increase my exponent by 1, and then divide by the raised exponent. And then at the end, I need to make sure to add on a constant. I can rewrite this a couple different ways. So I could rewrite it as 1/4 x to the 4th natural log of x minus 1/16 x to the 4th plus a constant. Or I could pull out 1/4 x to the 4th from each of the other terms. And here I would be left with a natural log of x. And then right here, I would be left just with plain 1/4. And we would still need to make sure to have our constant added at the end. And then just for notation, I usually forget to write these in the middle, but make sure you have your absolute value around all your natural log of x's.